Ever tried taking a photo in low light and ended up with a blurry, grainy mess? You're not alone. Low-light image enhancement is a massive challenge in computer vision, like trying to paint a masterpiece with a flickering candle. But here's the good news. Scientists are using smart AI to fix this, and one of the most exciting breakthroughs is called CWNet. Let's break down how it works and why it's a game changer. The problem is this. When you take a photo in the dark, the image is often noisy, washed out, or missing details. Traditional methods try to fix this by just brightening the whole picture. But that's like turning up the lights in a room. Everything gets brighter, but you lose the texture of the walls or the sparkle in someone's eye. CWNet takes a smarter approach. Instead of just making things brighter, it understands why the image is dark in the first place. Here's where it gets cool. CWNet uses causal reasoning. Think of it like solving a mystery. Instead of guessing what the image should look like, it asks, what's causing the darkness here? It separates the real details of the scene, like the curve of a face or the pattern of a rug, from the noise or color distortions that mess up the photo. This way, the AI doesn't just brighten the image, it preserves its true meaning. Then there's the wavelet transform, which is like a superpower for analyzing images. While traditional methods might look at an image as a whole, wavelets break it down into different scales. Imagine zooming in on a painting. Wavelets can spot the big brushstrokes and the tiny details, like the texture of the canvas. CWNet uses this to recover lost details without making the image look fake or overprocessed. But here's the real magic. CWNet works in two steps. First, it uses a metric learning strategy to filter out non-causal noise, like color shifts or brightness anomalies. Then it leverages CLIP, a language image model, to keep the image's meaning intact. Think of CLIP as a bridge between words and pictures. It ensures that the enhanced image still matches what's actually in the scene. So your friend's face stays recognizable, not just brighter. Researchers tested CWNet against other methods like SKF-SNR, UHDFormer, and WaveMamba. Most of these tools struggled. SKF-SNR overexposed skies, turning them into pale white blobs. UHDFormer blurred delicate details, like a flower's petals, into a mushy mess. Even WaveMamba smudged textures, making images look unsharp. But CWNet, it nailed the balance. Take a low-light photo of a flower. Other methods might make the petals too bright or erase their texture. CWNet, it preserves every detail while enhancing clarity. How does it do this? By using causal inference, think of it as a detective for images. The system identifies relationships between elements. If there's a shadow, it traces it back to its light source. By understanding these connections, CWNet makes changes without messing up the bigger picture. A tree stays a tree, even in the dark. And it's not just about making photos look better, it actually helps AI do its job better. In tests, when researchers used CWNet-enhanced images for object detection, the AI spotted pedestrians and traffic lights more accurately. While other methods missed a motorcycle or confused a red light with a green one, CWNet's clearer images gave the AI the boost it needed to see straight. The results? CWNet outperforms existing methods across the board. On datasets like nighttime cityscapes and indoor portraits, it achieves higher PSNR, a measure of brightness accuracy, better SSIM, how similar the image is to a perfect version, and lower LPIPS, a metric for how natural it looks. Plus, it's efficient, using fewer computational resources than other models, which means it can run faster on your phone or camera. So why does this matter? Beyond better photos, this tech could revolutionize fields like medical imaging, autonomous vehicles, or even space exploration, where low-light conditions are common. By balancing speed, accuracy, and detail, CWNet sets a new standard for image enhancement. Next time you snap a low-light photo, remember, science is working hard to turn those blurry shadows into clear, vibrant moments. Thanks for watching. If you want to dive deeper into how AI transforms images, hit subscribe. And drop a comment below. What's your go-to trick for low-light photography? See you next time.